conclude this series of lessons on the fundamentals of metrology, let's take a look at the governing bodies of metrology at the international level. Modern metrology began on the 20th of May 1875 in Paris when an important treaty, the Meter Convention, was signed. It is a treaty between states, initially signed by 17 states, including Italy, and now has 64 member states and 36 associate states. The treaty aimed at achieving the important goal of having a single system of measurement units necessary both to advance science and ensure fair trade and fair imposition of taxes and sanctions. To this end, the treaty established the General Conference on Weights and Measures, whose official name is in French, Conférence Générale des Poids et Mesures, abbreviated as CGPM, which is the highest governing body of metrology. The CGPM avails itself of the technical advice of the International Committee for Weights and Measures, whose official name again is in French, Comité International des Poids et Mesures, with acronym CIPM. This committee, in turn, avails itself of consultative committees on the various units. Alongside these two bodies, the Meter Convention established the International Bureau of Weights and Measures, better known by its official French name, Bureau International des Poids et Mesures, and the acronym BIPM. The mission of this body is to promote metrology at the international level, implement the decisions taken by the CGPM, and coordinate among themselves the national metrology institutes of the states that have signed the Meter Convention. What has been said so far can be broadly outlined in the diagram you see here. When the Meter Convention was signed, only 3 units of measurement were considered: the meter, the unit of length, the kilogram, the unit of mass, and the second, the unit of time. The first two were realized with physical prototypes, while the unit of time was based on astronomical observations. Nowadays, the International System of Units, known as the SI, has 7 fundamental units. In addition to the 3 mentioned earlier, we have the ampere, the unit of electric current, the Kelvin, the unit of temperature, the mole, the unit of amount of substance, and the candela, the unit of luminous intensity. They are all defined based on universal physical constants and do no longer rely on prototypes. For quite some time after the Meter Convention was signed, the member states ensured traceability of their own measurements with standards kept by their national metrology institutes, standards which were periodically compared with those held by the BIPM. With the globalization of commercial activities, having to refer to one's own national standards could become a barrier and an additional cost, since the results of measurements carried out in one country were not automatically recognized as valid in another country. To overcome these drawbacks, on the 14th of October 1999, another important international agreement was signed, the Mutual Recognition Arrangement, better known by its acronym MRA. With this agreement, the National Metrology Institutes committed to the mutual recognition of their own standards and, to ensure their metrological compatibility, agreed upon comparing them periodically through interlaboratory comparisons coordinated by the BIPM. However, as we saw in the previous lesson, the instruments used in routine measurement activities, including those for testing and inspecting industrial products, cannot be calibrated by direct comparison with the national standard, but only through an appropriate hierarchy of calibrations. It was therefore recognized that it was necessary to extend this agreement to the mutual recognition of measurement results from entities that could demonstrate the traceability of their measurements to national standards. This led in 2000 to the signing of the ILAC-MRA agreement, where ILAC stands for International Laboratory Accreditation Cooperation, and it is the international body that ensures the metrological compatibility of measurements carried out by accredited laboratories through compliance with dedicated international standards and the surveillance of accreditation bodies. To do this, ILAC operates through the regional bodies shown in this figure. These bodies coordinate and oversee the national accreditation bodies. For Europe, the regional body is European Cooperation for Accreditation, abbreviated as EA. The European Union, with Regulation 765 issued in 2008, established that each member state may have a single accreditation body, which in turn is accredited and overseen by the EA. For example, for Italy, this body is Accredia. The entire accreditation system is governed by the international standard ISO IEC 17011, Conformity Assessment, Requirements for Accreditation Bodies, Accrediting Conformity Assessment Bodies. In addition to this general standard, there are other specific standards that regulate the various measurement activities. In particular, the ISO IEC standard 17025, General Requirements for the Competence of Testing and Calibration Laboratories, establishes the requirements that test and calibration laboratories must meet to ensure the metrological traceability of the measurement results they provide. By complying with these requirements, it can be granted that measurement results can be traced back to national standards through the documented unbroken chain of calibrations referred to by the VIM in the definition of metrological traceability. The standard, therefore, recommends how to document measurement activities and also specifies the technical competence requirements for those carrying out the measurements, as well as how they should be assessed. If all of these requirements are met, the accreditation body accredits the laboratory, ensuring through its surveillance that the measurement results provided are traceable to the primary standards within the stated uncertainty limits. To summarize, we have briefly reviewed the main steps that have led to the current international metrology system and to the mutual recognition of measurement results, provided that they are supplied by an accredited laboratory. More generally, in this series of lectures, we have analyzed the principles underlying modern metrology and how it is possible to ensure that the measurement results obtained are suitable for their intended use.